I'm going to show you one more example, since these problems are pretty tough, before we move on to clearing fractions and decimals in section 2.3. So same rules are going to apply. We're going to be using all of our rules from, oops, grabbed the wrong sheet, here it is, from 2 through 7. And let's just get started. So distributive property comes first. 7y plus, write it underneath since I don't have room on top, 2 minus 8y is equal to 8y minus 5y minus 20. Don't forget that that negative has to go with you when you multiply by the 4. Combining like terms on each side, 7y's take away 8y's will leave me with a negative 1y plus 2. And it is okay to just write this as negative y. I think sometimes, though, at this level, having that 1 there reminds you of what negative y means, that it means that you have a negative 1y. On the other side, 8y take away 5y leaves you with 3y, and there's still 20 more to take away. Then I'm going to collect all my terms on the same side. Here's the first one that we've done as an example where it seems like it might make more sense to move these over here. If you still want to subtract 3y from both sides, there's nothing wrong with that. It doesn't matter. Many people just like their variable term on the left. But I want to show you that you can move all your variables to the right and it won't change the response, that it's okay to do that. So I can get rid of this subtract a y or this negative 1y by adding 1y to that side. It'll make my y's go away and leave me with just the 2. But the golden rule says if I'm going to add a y on the left, I need to add a y on the right. So I'll have a total of 4 y's minus 20 on that side. Now, since I'm trying to isolate my variable, I still want y alone. Instead of subtracting 2 from both sides, which is just going to get more stuff next to the y, I'm going to add 20 to both sides. So now, since my y is on the right, I'm moving all of the other stuff over to the left. The point I'm making is that the rule doesn't say that you have to isolate the variable on the left. It just says you have to isolate the variable. So it's perfectly fine to isolate it on the right as long as you're keeping this equation balanced while you do it. So I'm going to add 20 to both sides. That'll give me 22 on the left, 4y on the right. I'll divide through by 4, and the farthest that I can simplify the fraction 22/4 is to get 11 halves. If you want to go ahead and do that division, you'll see that it comes out to be a 5.5 or a 5.5y. We haven't talked much about doing checks with decimal numbers, since decimal numbers are assumed to be a skill you already have in this class. We've been checking everything with our fractions, but I figured doing 1 with a decimal wouldn't hurt. Since the fraction 11 halves can truly be written as a decimal, a terminating decimal of 5.5, it's okay to check your work with the decimal version of the answer. Now, if this would come out to be 11/3, which simplifies to 3 1/3, 3.3333333, you cannot write enough 3's to make it truly equal y. So if this fraction had a 3 in the bottom, it would not be okay to check it with its decimal version. But because this fraction does write a decimal that terminates, a decimal that really does end after that very first 5 in the decimal place, it's okay to use the decimal version when we do our check. So let's do the check. We're going to have 7 times 5.5 plus 2 times 1 minus 4 times 5.5 is equal to 8 times 5.5 minus 5 times 5.5 plus 4. So we need to take care of parentheses first as we're doing order of operations to simplify each of these two expressions. So looking at the first side, I'm doing 4 times 5.5. The way I do that in my head, I look at 4 times 5 and say that's 20. But then I also have to find 4 times half, or 4 times 0.5, and that's going to be 2. So this becomes 1 minus 22, because 4 times 5.5 is going to come out to be the whole number 22. That whole thing's getting multiplied by a 2, and the 7 times 5.5, well, 7 times 5 is 35, and then 7 times half is 3.5, 3 and a half, so that's going to give me a total of 38.5 on that side. 38.5 plus 2 times a negative 21, because 1 minus 22 is going to give me negative 21, is going to be 38.5 minus, actually, because 2 times a negative 21 is going to give me a negative 42. And then I have to come down here and do that math by writing it out. I do subtraction with decimal numbers by adding a 0 after the 2, so that I have a decimal place to take the 5 away from. That's going to be 5. Now I can't take 1 away, or 8 away from 1, so I have to borrow again. So 3.5, but remember, my 42 was the bigger number. 38.5 was the smaller number. So the answer is going to be a negative 3.5. Now let's see if this side comes out to be the same thing. Simplifying inside my parentheses first, I'll just copy the 8 times 5.5 minus 5. And then 5.5 plus 4 is going to give me 9.5. Doing the multiplication the same way, I'm going to do 8 times 5, which is 40. 8 times half is 4, so that gives me 44. 5 times 9 is 45, and half of 5 is 2.5, so that's going to give me 47.5. And then I'll come down here and do the subtraction again. 47.5 minus 44 is a 0.5, 3.5. And remember, the 47.5 was the larger number, and it was negative. So the difference here, it's not really 47.5 minus 5, or minus 44, it's negative 47.5 plus 44. So the answer is going to come out to be a negative 3.5. If you did carry through your check with the fraction 11 halves, a negative 3.5 is the same thing as 3 1/2, which would be the same thing as 7 halves. So a negative 7 halves would be the check that you get for this problem if you checked it with the fraction 11 halves instead. So either one of those would work as show work for your check.